So let's go over multiplication of fractions, and it's pretty straightforward, but it does work a little differently to subtraction and multiplication. So let's have a look at this first example here. 1/4 or 1/4 times 2/8. Oh my goodness. Imagine if I forgot the rule and I was in a quiz. So I always do this. When we say a half of something, the of means multiply. So if I said, for example, a half of a half, if I drew that out, here's my half, not very accurate. Let me make it a bit more accurate. So this is my half. If I was to make a half of it, I'd half that half again, and here's my half of a half, and it's a fourth. So let's see if that works. And when we are multiplying fractions, we just multiply the numerator, the number on the top, and the denominator, the number on the bottom. So we have 1 times 1 is 1. Yeah, that looks about right. And 2 times 2 is 4. Yes. So I've got the rule right in my head. Okay. Now, if I had 8 pieces, and there's a cake with 8 pieces, and then I want half of one of those eighths, it would divide the cake into 16 pieces. So at least that part would be a 16th. So let's see if that rule applies again. 1 times 1 is 1, okay, and 2 times 8 is 16. Yes, that means that my rule is secure and I'm using the correct method. All right, let's go to the more complex ones. So firstly, we can cancel down like across diagonally, or we can cancel down and down, but never across. We can't do that. So can we cancel down this way? A 1 and an 8? Nope. Can we cancel down up and down? Yes, we can. So let's have a look. You can choose because you can also cancel down diagonally. That's also an option. But let's do it like this. Actually, we look for a number that goes into both the numerator and the denominator exactly without any remainders. But it must be the same number. Like, for example, down here, we couldn't say 3 divided by 3 and 5 divided by 5 because it would give us completely the wrong answer. So it must be the same divisor. So 2 divided by 2, that's okay, 1. And then 8 divided by 2, that's a fourth or a quarter. There we go. Let me just get rid of that. And remember, as you're working out, you might have to adjust how you present your work, and that's fine. Use your eraser. And now we can go ahead. So we've got a new version of this original question. So this was the original question. Now we have a new version of it here. A little messy, but we can live with that. 1 times 1, that's 1. And then 4 times 4, well, that's 16. And that's your answer. Now, let's look at a more complex one. Remember, we can cancel down diagonally in an X or up and down, but never across. Okay, so can we cancel down anything here? 3 and 12 could be cancelled down, or 4 and 12. Let's go for 4 and 12. It really doesn't matter. So 4 must be the same divisor, same number going into it. 4 divided by 4 is 4. And 12 divided by 4, sorry, 4 divided by 4 is not 4. 4 divided by 4 is 1. Okay, now let's look at the next one. And 12 divided by 4, that is 3. It goes in there 3 times. And we'll know that because 3 times 4 equals 12. This is why your teacher is always talking about learning with times tables, because once you have those times tables, this part becomes really easy. Now we have a whole new sum. Here we go. We've got 1/3 multiplied by 3/5. Can we cancel down again? I do believe that we can. We can do it crossways. So divide that by 3 and divide that by 3. Oh, this is nice. So now we have 1 over 1 times 1 over 5. How lovely. And we just multiply across. 1 times 1 is 1. 1 times 5 is 5. And that's the answer. And that is all there is to it. So when we pan back and we look at our whole page, my goodness, there's an awful lot of working out. And that's why sometimes multiplication of fractions can look so daunting. but actually it's just one big jumble of numbers, but we know this is our answer here. We know this is our answer here. And here are our answers. And usually on our quiz, they will leave us a box here. And you can just pop your answer in that box. And all this working out is just our brain work, our math talk that's inside our head. So if you have any questions, just let me know.